All right, guys, in today's video, we're going to be working on this 2004 Chevrolet Cavalier again. It's got an AC performance problem. So the AC system is working, but we're not getting the kind of cooling out of it that we would expect. All right, so the owner is complaining that it's not as cold as it was in the previous summer season. We repaired a leak on this previously on the AC compressor hose, the primary hose, and I'll put a link to that up here in the upper right of the video if you want to see that. But now that the leaks are fixed and it's holding the proper refrigerant charge, it's still not where it needs to be. So what are we going to do in this video? I'm going to show you how to use a gauge set and some simple tests to go determine where in the system are we getting this failure in performance, right? So the first thing we're going to be doing is we're going to be making sure that the gauge set, the valves that control the service valve couplers, are going to be closed in the closed position, and we're going to be making sure that the manifold valves are in the closed position, and we're going to take the charge hose and hook it up to a vacuum pump. And the reason we're doing this is we got to take the moisture out of these lines before we hook them up to the actual vehicle system. So what we'll see is, as we open this up, it'll suck all the air in this hose and in this hose. And we just want to do that because we don't want any atmospheric contamination getting in the system when we use this, right? So at this point, this guy is under a vacuum. We can disconnect it from the vacuum pump, as long as you've got a valve on the end of your vacuum hose, your charge hose, and then as long as we keep this closed up, we've got this vacuum. And so now what we can do is we can set these up on the actual vehicle. So on this particular vehicle with this blue cap, this guy up here is the low side coupler. We're not going to open them just yet. We're just going to get them in a position. Now, in this particular vehicle, and this vehicle is going to cover 2002 to 2005 Chevrolet Cavalier and Pontiac Sunfire, it's really hard to see. So let me get the camera in another position here, but the high side valve is actually under this metal cross member. All right, guys, this is a better view, hopefully. So you see here's the red cap for that high side connector. I'm going to block your view just even getting the cap off. There's no way I'm going to show contorting around to get the coupler on there, but that's the service fitting that you've got to get the coupler onto. All right, so we've got that on there. It's a real pisser to get on there, particularly if the engine's been driven like this one where this is all hot under here, but it can be done, and that's what has to be done. All right, guys, from the inside, we're going to start the engine up. We're going to put the AC on, put the fan on. We're going to leave it with the center vents because I want to concentrate the airflow up here, and then we're going to insert a thermometer in the left center vent. And right now you can see the reading looks like just a little bit above 80 degrees. We're going to give it a couple of minutes, and then we're going to go under the hood and we're going to open up the service valves for the gauges. All right. Again, with these two valves remaining closed, we're going to come down here, we're going to open up these valves. So we're going to start with opening up this low side first. Just 2 or 3 fingers, you don't want to crank down on it. As soon as you get some resistance, you're done. All right, so we're reading just under 50. I'm going to go reach my hand under the front here and do the same thing with this high side valve, and you guys can watch up there. All right. So we're reading what looks like around 49 on the low side, and maybe around, so that middle mark's 175, maybe around 170. We're just going to let this stabilize for about 5 minutes. And then we're going to come back and we're going to record these two values. Alright guys, it's been 5 minutes, and what we can see here on the PSI portion of the gauge, we're sitting just right at 50. Right at 50 PSI. So this is really too high for the low side. And then on the high side, again using the PSI pounds per square inch portion of the ring on the gauge, we are sitting just shy of 175, right? So I would probably call it 170. So now we're going to go inside the vehicle and we're going to check the temperature that we had inside. All right, on the inside, we're reading what looks like 60 degrees, at best 59, right? Let's give it the benefit of the doubt and say it's 59. So we're going to write that number down here. So if we take a look at what we're writing down, so we've got 59 degrees on the left center vent temperature. Our low side pressure was 50 psi. Our high side pressure was 174 psi. Some other things that we can write down is the outside temperature currently is 93 degrees Fahrenheit. So these are all Fahrenheit measurements. And the outside humidity right now is 52%. We're going to need all of this information. We've got two more pieces of information we need to go get under the hood. That's the low side pipe temperature. This is a subjective measurement with your hand, and the high side pipe temperature. So what we're going to do is we're going to shut everything down. We're going to feel those pipes, and we're going to determine, do they feel hot, warm, cool, or cold, and we're going to jot down what that is, and we're going to feed all of this into a service manual troubleshooting procedure. So at this point, we're going to shut everything down, and within a minute or so, we want to go in and complete this next step. So let's go back under the hood. All right, let's look at the gauges first. As we walk back in with the engine shut off, the pressures are going to start to equalize between the low and the high side. So we see the low creeping up, and we see the high coming down. So we want to see that happens. So that's a good thing. So eventually we should be reading about the same. So now we're going to make this subjective measurement on the low side pipe. So if I grab this pipe, it definitely feels cool, somewhere between cool and cold. It's obviously not too cold to touch. So I'm going to call that cool. And on the high side pipe, I'm just going to reach under here. This is usually hot. So be careful when you reach under here. And this is no exception. This pipe is definitely hot. All right, so at this point, all we just want to see is, does this guy eventually equalize? And I think he has. We're reading about 79 psi on the low side. These are roughly in 5 psi ticks. So 95, 90, 85. They're very close. So I'd say we're reading 85 psi on the high side and about 79, 70. 79-ish or so on the low side. So I think this is going to equalize if we give it more time. So the next thing that we're going to do is we're going to close off the high side service port down here. So I won't be able to show you that because of the cramped corners, but you guys know what we're talking about here. We're going to close this off. And with that closed off, hopefully we can get this with one hand here. We're going to remove this pipe, this coupler. All right, so with that closed, this line is holding pressure. We're going to go ahead and open this valve to let that pressure into the manifold. And then what we're going to do, we've got a lot more refrigerant sitting in this high side from what we did our testing. We're going to start the engine back up, and we're going to suck some of this out into the low side before we go to the service manual. All right, with the engine started again, our low side is going to slowly creep back up. We've left this the way we had it, so it's still open. And all we're going to do is we're going to slowly open this valve to try to suck some of this pressure out. You see that's going down. Open that up all the way. and then we can close it. Now we're done. All right, and with the engine shut off again, we can reclose the low side service port, remove it from the vehicle line. Let's go ahead and take a look at the service manual. All right, guys, I'm just letting out the residual refrigerant that's trapped in the line from that exercise we did before so that we're all back to zero so that we can stow this because we're not going to need it for the next step. We're going to use a different machine. All right, so taking a look at the service manual and going over to this section here, what they're going to talk to you about is the system performance test. Right, and so we've done this, but I'll show you these steps. But they have a dedicated machine that plugs in and does the temperature and the pressure analysis. We've done this all with separate aftermarket type tools. But they basically are going to tell you, capture that ambient air temperature, which we did, record the high and the low side pressure. Now they're talking about the static pressure, which is without the engine running. We just went straight to the next step on the engine running. And then they're going to ask you to take a look at what you're getting. And if you're not getting what's in these values, they're going to tell you to go to the next step. And the next step is going to be get the AC turned on, get the temperature set to the coldest position, get it blowing through the front vents, install the temperature sensor into the center IP outlets, and then start the engine and operate it for 5 minutes, right? And so that's what we've done. And they ask you, did it fall in the ranges that are specified in the performance table? I'll show you that in a minute. In our case, it's no. They're going to tell you to go ahead and run it again, reset the temperatures, compare it again, and if it still doesn't fail, then go into the diagnostics, and they have a bunch of different tables that they'll walk you through. I'm going to show you a shortcut, so we're just going to go straight to this performance table. Every GM vehicle's got something like this in the service manual, but it's not always the same. So the first thing we're going to go do for this particular vehicle, our outside temperature was 93 degrees and our humidity was 52%. We're going to come down at the ambient air temperature. We're going to find 93 degrees Fahrenheit. That's this row. Greater than 30% relative humidity. That's this row. We should be reading between 30 and 41 psi on this particular vehicle. So this video data is only for the vehicles that's in the video title and description. And our high side should be 203 to 282. So we're definitely reading too high here and too low there. So where that puts us on the diagnostic table is all these different temperatures correspond to letter codes that tell you where the diag is. So if the low side is about 50 psi and the high side is about 174, that's going to put us squarely in this B zone. And if we take a look at the B zone diagnostics, this is A, this is B. So they said, were you sent here from the performance test? Yes. It asks you, now I'm going to show you two different ways for this because we did this other video that I talked about. They ask you, did the pressures equalize or become static? I showed you that they do. And so they would tell you to go to step 5, which is the most common cause for that is a low refrigerant charge. They want you to evacuate, recharge the system, check for leaks. We already did that as part of the previous video. And we would just go straight down to step 6, and it would say, read these pressures, take the air temperature, go compare that to the performance chart. If it's still not in compliance, go straight to step 7 and replace the AC compressor. And as part of that, they want you to look at the orifice tube first. Right? And then there's a number of steps because you may have to replace the orifice tube as well. With GM, it's not an automatic parts cannon where you just replace everything. You only replace the part that's failed, and you do tests to determine if other parts need to be replaced with it. So let's say that we didn't have that previous repair and that we went through it and we did this recharge. Well, that would have caused us to go down this other leg of the tree on step 3. I'm just showing you both flavors of it. And they would say, well, is the low side pressure equal to or greater than the range in the table? In our case, it's greater. Is the high side less than what's in the table? In our side, it is. And then how does it feel? Is the low side cool to warm? And is the high side warm to hot? In our case, we said yes to all of these, and it would again suspect a refrigerant charge problem, and it would take you down to step 5 again. And so we would end up again on this path that puts us down to the compressor. So no matter how you answer that first question, you get to it's a compressor problem. that we have these pressures as long as we've eliminated the refrigerant as a cause, and we have in this particular vehicle's case. All right, so if we continue on, it wants you to remove the orifice tube, and they want you to start doing some questions. They're going to say, did you see some metal flakes on the orifice tube? When they say expansion device, they mean orifice tube here, as you see up there. And if you said no, then they would take you to the next step, and they would say, do you see any brown powdery residue? And if you said yes, they would say, well, then you need to flush the system out and before you replace the compressor, and then also replace the accumulator. If you said no, then they would jump you down here and they would say, all right, you don't need to flush the system and you don't need to replace the accumulator, just replace the compressor. So depending on what that orifice tube looks like is going to dictate whether our repair is just the compressor or more than the compressor. So let's take a look at what's involved with removing that orifice tube. So I dog-eared that page back here. So orifice tube replacement. And all of this presumes that you understand that you have to evacuate the refrigerant first. You've got to evacuate the refrigerant. You can't start removing fasteners and taking things apart while it's full of refrigerant. That can be dangerous. You could end up with frostbite, cause blindness if it gets in your eyes, and also it's against the law, right? So there's a whole bunch of reasons you've got to evacuate. And I'll show you evacuating the refrigerant here briefly with the machine. But when we get it evacuated, we're going to go after this disassembly here to take a look at this little guy. It's in there. He's plastic. He looks like this, and we're going to do those inspections. All right, folks, we've got the recovery set up. Just like with the gauge set, we're going to have to vacuum the atmospheric air moisture out of these lines and the equipment before we use it to recover the R134A refrigerant. This is our filter dryer unit that does the separation of oil as well as filter and recover the actual refrigerant from the vehicle, and that is pulled through the recovery machine that's sitting here on the ground. Everything I use is a brand of equipment from a company called Mastercool. There's lots of different brands out there. I like this brand. And then that goes over into our recovery cylinder, where the scale is located for weighing how much refrigerant we recover. And then finally, we've got our vacuum line going to the actual vacuum pump. We're just going to let this run for about 15 minutes, then we're going to get started. All right, so after you run the vacuum for that much time, you're going to check that the gauges are showing a vacuum. In my case, I've got two sets. I've got one on this device here, and then we've got the gauges on the actual recovery system also showing a vacuum. And what we're going to want to see is we're going to want to wait 15 minutes or so. We want to make sure there's no leaks, because if we got leaks in this cabling that we have, we're going to have leaks trying to recover the refrigerant. All right, guys, we've started the refrigerant recovery process. We've got the recovery machine on the floor running, and it's going to charge up the cylinder through the low side port, and we'll be able to track that progress using the scale. So it doesn't take too long. We'll come back here when she's all done. All right, guys, we finished recovering our refrigerant charge. At this point, I've hooked the vacuum back up to this setup. We're just vacuuming out the very, very small amount of residual refrigerant that these recovery machines are not able to access. And we're getting that out of the lines and out of the equipment as well as out of the vehicle system before we open it up to inspect that orifice tube. All right, we've got our equipment out of the way. We've got a vacuum on the system. Now we need to go after the orifice tube for that last inspection before we make the repair. So we want to take note of this line that's running along the front of the surge tank right here. And if you follow this line over, that's where you'll find where the orifice tube is at, right? So not really a good spot for me to put this light, but right down here where the end of that tube is. So we've got this tube right here where my finger is. Right there. So right under my fingers where the orifice tube is, right? So if we pull out, it's once again in a convenient location, just like the high side port. To get some access, we're going to remove this panel cover here. There's several of these push pin type retainers. Pull up the middle, then we can pull up the rest of it. And if we pull these out real quick, last one's right over here by the battery. Then it loops under the fender on both sides, and then it just comes out. That's one thing we have to get out of the way in order to get in here. And then the next thing we're going to have to do is we're going to have to grab a socket. We're going to have to pull this headlight out. That'll let us get access to this orifice tube. Now the service manual recommends you pull the surge tank, pull these lines, drain the coolant, and remove this whole access line that I was showing you, but I'm going to show you the shortcut where you come in from where the headlight is. All right, it is a 13 millimeter, so we'll pull both of these passenger side headlight fasteners out. And with these out of the way, this guy's just held in with like a spring retainer. We'll go ahead and get the wiring harness released right here. Get this side marker harness with this bulb. Give this a squeeze, twist this with this turn signal bulb, and just gently let them sit down here so they don't get damaged. This spring I was referring to is normally held onto here. Looks like it did not come off with the unit. Should have stayed on like that. Not sure why it didn't go. So what we'll do is we'll give it a pinch with a pair of pliers to get to hold on better. All right, let me go do that and we'll come back and continue. All right, with the headlight out of the way, there's what we're after. Just going to kind of clean off any dust and sand and dirt and crap that might be on it, because we don't want anything to fall in when we separate these pieces. All right, so that's a 13 on the top. So we come in here with this breaker bar here. Just release the clamping force. This will probably be the easy part. Getting it separated will be the hard part. Just a little bit of corrosion on this stud that's going to fight us near the end. I don't like to use penetrating oil on these air conditioning fittings, so you don't want to get any of that to ooze into the system. All right, so this is coming off. Now we just need to get this to separate. So she is turning. If I can get myself situated to pull up on this pipe. All right, there it goes. And you heard the vacuum. And there's our orifice tube. But we don't have enough clearance to pull this out. So let's see, what do we need to move out of the way back here? I mean, I'm hoping that we can avoid pulling the surge tank and draining the coolant for this. There's nothing holding this line. It's rubbing up against the AC compressor. We can move this up a little bit. I think we can make this work. I think. All right, so what we're hitting now is the hood prop. That's what. Nope, right here. So another engineering marvel here. So we want to separate this guy from the pipe. This orifice tube. It's been sitting in here, guys, for 20 years, I'm sure. There we go. All right. And so if I can just get this like that. Find the right grasping tool. There we go. All right, so what do we see? Well, we don't see brown. What we see is like a fine black powder, and then you see up here we have some metallic particles. And so this is wear of the compressor. So what I'm looking for is if we have any brown as well. So like I showed you in the service manual, if we can find a reasonably clean part of our rag here. We're not going to reuse this tube, so it really doesn't matter. I want to see, is it always black or is there any brown? If there's no brown, then the accumulator is okay. What's the brown? The brown means that the desiccant material that's inside the accumulator has degraded or broken down. So this is all black along with some metallic pieces. All we have to do is replace this guy. So let's go get a new one of these, and then just for grins, let me show you what I was referring to about the accumulator. You guys should know this to be doing this kind of work, but if we follow this compressor pipe over, this big guy here, this is the accumulator. Inside of here is a desiccant material that is designed to remove minute amounts of moisture that might get into the system. It's also a reservoir for the PAG oil that lubricates the system. So this guy's okay. The orifice tube's got to be replaced and the compressor's got to be replaced. So let's go get the new orifice tube. All right, let's put a paper towel over the opening to the condenser. First thing I want to do is get the old O-ring off of this pipe. You guys can see underneath here. Just want to do it really gently so that nothing scratches. You got to replace the seals. All right, and then we're going to clean up anything that might be on this pipe. There's some residual old material from this 20-year-old seal on here. So just make some of that off of there. All right, and then we'll replace that seal. It's going to be an AC Delco 153978 or a GM 5245 6067. Like a bag in a bag kind of deal. Just want to get one of these out of here. Come on. All right. And then we're going to be lubricating things with some AC Delco refrigerant oil. For R134A, this is AC Delco 15118, GM 1235, 6151. Just going to take a drop of this just to help ease the assembly here, because this is not the best position for this to be in. I don't know how much you guys are going to be able to see, but we want to get this on without nicking it. So we got to kind of stretch it over this tube underneath. So if we bring the camera more level, you can see it's got a little recess that it fits in. So we just want to get this rolled up into that recess like that, and we're good to go. All right, so next thing is the orifice tube. So we pull back a bit. We're going to replace that with an AC Delco 155378 or a GM 3096068. This is what they should look like. So if we compare this with our original one, now you can't judge this plastic up here because they may have been black plastic originally. We're just looking at the screen portion. You can see how obstructed the screen is on the original one compared to this new one. All right, just like we did with that seal, there's an O-ring seal right here built into the orifice tube. We need to give that a drop of pag oil also to ease the assembly. You do not want to touch this screen, and you don't want to let it make contact with any of this dirty part of the vehicle. So I'm trying to see the best way to get this in here without doing that. Just going to kind of get it lined up and just plop it in just like that. And then just going to tap it till it goes all the way. And then, as you see, it's got like a little plush shape to the top. And when we push the pipe down, it's going to push it more. So it's going to self-seat itself. We just got to get the, the nipple to fit into the male part of the pipe to fit into the female part of the pipe. That's what we're dealing with right now. All right, get the nut that we had on here. And we're going to tighten this down to 12 foot-pounds. Oops, where's our socket? Not going to get very far without a socket. Let's go ahead and do this to get it started. We got this radiator pipe right in the way. But by putting that pag oil on here, everything will lube up and seat in very nicely. All right, when it feels snug with the regular wrench, then we can switch to the torque wrench, and again, 12 foot-pounds, and we're done with this step. If we can get the torque wrench to fit in here. It's always something. It's always something. All right, we've got the headlight reinstalled, 40 inch-pounds on the fastener here and down here. And then in the back here, you want to make sure that you see this little prong we were talking about comes through and locks into position. Of course, also make sure you rehook up the electrical connectors. Because that condenser tube shifted, we've gone ahead and put a vacuum on this guy again, and we're just going to make sure that there's no leaks before we continue. Just a 15-minute check, and then we're going to go get the car lifted up and replace the compressor itself. All right, guys, now that we've done the orifice tube, let's come back to where we left off in the service manual. Right, so it had already dropped us into this section about the compressor malfunctioning, but they want us to inspect the orifice tube and see if we had metal flakes on the filter. And this is the yes column and this is the no column. In our case, it's a yes. We went ahead and also inspected just in case it was a no. If we said that we didn't have those metal flakes, just to show you both legs of the tree, it would have taken us to step 8 and it would have said, do you see any brown powdery residue? And that would have been an indication that if we said yes, it would have dropped us down and said, flush the AC system, replace the orifice tube, and still replace the compressor, but also replace the accumulator, right? So we didn't have this. So basically where we left off is we took just metal flakes, yes, so we jumped to step 9, and then removed the compressor hose. Now, the video I linked for you up above earlier was we already did this compressor hose. And so I still have the old one, and there are no metal flakes inside the old hose. So the only ones we have are on the filter. So what do you do in that situation? Well, if we say no, we drop us down to 12, replace the compressor, evacuate and recharge the system, and you're done. You're going to go back and re-verify that everything's normal. If we had found metal flakes in that compressor hose, we would have went down to 10, still would have replaced the compressor. They would have recommended installing a AC refrigerant filter because those metal pieces could potentially have circulated around to the condenser or the evaporator. We still would have replaced the orifice tube, and then we would have evacuated and recharged the system. So you notice we would not replace the accumulator in this particular failure scenario. I'll put links in the video description to what they're talking about here for this refrigerant filter. We didn't have this situation, so we didn't do it. So all we're going to do to wrap up this repair is we're just going to go down and pull the compressor. We're going to get this lifted up and do that now. All right, here's our compressor. We pulled this 7mm bolts or screws rather, and 3 fir tree fasteners in order to get this plastic piece out so you guys can see what I'm doing. You'll also need that access to release the tension on the belt. First thing I'm going to do is I'm going to come over here though and get this electrical connector off. So there's tabs on each side. We need to work off without breaking. And if it hasn't been off in a while, it's going to be really stubborn, but if you're patient, it'll come off. All right, so that's the electrical connector. I tuck this up over here and out of our way. We've got 3 13s, one here, and one that you probably can't see right back here that attach the compressor to the engine. And then we've got one bolt here that's holding the pipe that goes to the AC system. So we're going to have to remove that bolt and these 3, but the first thing we're going to do next is we're going to get the tension on the belt. So you're going to need a tool to get the tensioner right up here. Right. Just going to need to lift this guy up enough to get the belt off. That's why, main reason you got to get this piece of trim out of here, so you can get this tool that we just used, so we can get this off out of the way. All right, let's get that out of the way now. So now we're going to take these 13s and loosen them up. One thing I noticed on this compressor is this is the original compressor from 2004. I am very amazed. So this thing made 21 years. I'll release this one back here as well. All right, and then I'm going to have to get this other one with an extension. I'll get that, and then we'll come back and we'll pull this compressor hose. Since this one is like impossible to see, I'm just going to take it all the way out now. All right, guys, now let's take this 13 off the top here. It's a real pisser to get in here from the top if it comes off. Come on, get on there. There we go. I already took 2 of the mounting bolts off. So it's only being held on by 1 right now, so I just want to work this guy off. So I'm going to go ahead and work this off. You guys don't need to see me struggle with getting this guy out from on top, but that's the technique, and then we can come back down below and finish up. All right, we'll finish this compressor hose bolt. And now we'll work our hose loose. Just like that. And then we got 1 bolt left right here in the front, and this guy's out. For this one, make sure you're bracing. So I'm going to take this back bolt out. Take this top bolt out that I got before. And then we're just going to finish this one down here on the bottom. Don't let it surprise you with the drop. It's heavy. And then we just bring her down. All right, let's put her on the bench and compare to what we're working on. We're going to have to take these seals and replace those as well. These guys right here. So while you're down here, you can go ahead and pull those off, just like we did for the orifice tube mount. And then we'll clean off these nipples. All right, here's our side-by-side comparison, new, old. Looks like our original one that made it 21 years was made in Brazil. So hats off to the GM team in Brazil from 2004. The replacement is made in Mexico, and it's going to be a 1589-3103. I'll put a link to this in the description along with the AC Delco number. And in the directions that it comes with, we already unboxed this guy. Save a little time. We're going to get 2 new seals, just like those old ones we took off the compressor hose. So we'll slide those on with some PAG oil. And then the instructions, I just want to see when it's sealed up like this, there should be a vacuum when you pull this off. I already checked this off camera, so it was under a vacuum. That's a good sign. That's usually a sign that there's oil in it, but it says here that they want you to drain the oil from the old compressor into a calibrated measuring container. This is pretty typical for GM procedures. Drain it from both the rear head port and from the crankcase drain bolt hole. So they mean draining it from here where the hose connects, and then on the back there is a drain plug. It's so covered with crud it's hard for me to see it. To get some of this cleaned up, I think it might be this guy right here. I'm not sure. I have to go check a look at the service manual and confirm which of those on the back is the drain plug on this particular model compressor. Record the amount of oil removed from the old compressor. You can just throw this out with motor oil as far as recycling it. And they just want you to know if the amount you got out of the old compressor is less than or equal to 2.5 ounces, then you don't need to add any additional oil to the new compressors. If the amount of oil in step 1 is greater than 2.5 ounces, then add enough PAG oil in the amount that it exceeded. So let's say you drained 3.5 from the old compressor, then you would add 1 to the new compressor. And I would tell you we actually will add that new oil in the form of dye if we have to go that route. Torque the drain bolt. So if you took the drain bolt off for whatever reason, you would torque it down to up to 12.5 foot-pounds. Rotate the clutch to lubricate and the swash plate and the piston shoes. What they're talking about that is before you install this guy, any oil you add, they just want you to turn this around several times to get the oil all lubricated in. It's been sitting in the box for who knows how long. And then, so they're telling you if you repaste any additional components, add the additional oil to the compressor to compensate. So if you replace the evaporator, add 1.5 ounces. If you replace the condenser, add 1. Let's see, orifice tube systems 1.5 ounces plus. So we didn't have any of this. We didn't replace any of these things, so we're just going to go with what's in the compressor. All right, let me get something to measure this, and we'll drain the old compressor oil out and see what we got. All right, guys, this is what I use for these kind of jobs. It's just a graduated cylinder, little funnel on top. So we're going to drain out what's in this old guy first. I already wiped around the edge to try and avoid some of the debris falling out of here. I would expect to get something out of here. It's possible that the system lost some oil in that leak that was fixed in the previous video. That could have been what finished off our little 21-year-old compressor here. Let's go ahead and check the drain plug. Right here on the bottom on this model, 13 millimeter. Let's see if we get anything out of that. Yeah, we got something out of that. Turn this thing around. So that's encouraging that it wasn't completely empty. Whoa, lost some. We're going to have to quickly estimate how much that spillage was. That's unfortunate. And yes, this guy's going to be heavy for this process. Just going to move it around a little bit. All right, let's set this like this. Let me get a tool to scoop up the spillage, and then we'll see if we got anything left in here. Honestly, don't think we got more than a little drizzle here. Not even enough that I can, just a few drops. So we're going to estimate that we've got just a fraction of a notch on the cylinder here with what accidentally spilled when we tilted that guy. All right, sorry about that, guys. So a little bit down here as well. Just drops here and there. All right, so what do we got here? So we've got, in milliliters, looks like about 32 milliliters. 32 milliliters, that's what I'm going to say we had in here. So let's see if we got any more. So we might just call it 33 with the spillage. Let's see if we get anything else out of here. Tilt it like this. Tilt it like this. Rotate it. Nope, she's empty. Well, little tiny drizzle came out there. So we'll go like this. We'll go like that. Just get a few extra drops. What does that put us up to? 33. So we'd call that 34. If we look at the directions, what they told us was they've got 74 milliliters in there. So we have less than 74, so we're done. We don't add anything. The only difference is that I want to have dye in here like we've got now. So I am going to drain the new one out, and we're going to replace that with some dye. All right, guys, now let's focus on the new one. So we know there's no way we need to worry about the old one having too much because we got 33, 34 milliliters tops. Maybe there was another milliliter left in there, right? So we're not going to find the 74. So this guy here should have 74. Take this plunger thing off that I was telling you about. You want to see if it feels wet. That's a good sign that the oil is in there, and you want to see if it was under a vacuum. Now what I'm looking at here is I'm looking for the dye, and that tells me I'm done. I don't need to add any dye because I see it already in there, so that's great. What I was about to add was this AC Delco tracer dye, AC Delco 15120 or GM12346287. This is 1/4 of an ounce, I believe. Where is it? Yeah, 1/4 of an ounce, which is 7 milliliters. So we were going to take out about 7 milliliters and replace it with this, but since it's already got a dye, we're done. So at this point, we're going to go back under the vehicle. We're going to mount this. Those 3 13 millimeter mounting bolts are going to get torqued to 16 foot-pounds. We're going to snap the electrical connector back on. We're going to put the belt back on. We're going to take that 13 millimeter that holds the compressor hose, and that's going to get torqued to 12 foot-pounds. And then, of course, we're going to put our new seals on that the compressor came with, and we'll be able to then recharge the system. So I'm not going to walk through all of this reassembly because it's just the reverse of the disassembly we already showed. Let me get part of this mounted. I'll show you where we are at different steps as usual. Okay, guys, we've got the new compressor installed. We've got those 3 long 13s torqued to 16 foot-pounds. From the service manual, we've got the short 13 that secures the compressor hose with the new seals torqued to 12 foot-pounds. We've got our electrical connector reinstalled, and we've got our serpentine belt reinstalled on the pulley. And you can hear in the background this time we're pulling a vacuum on the system yet again. We're going to pull it for 30 minutes, and then we're going to monitor it for 30 minutes for leaks, and then we're going to recharge it. All right, guys, we got this panel back in. These bolts that are all along the edge here, like these are all 7 millimeter. There's no specific torque value. These and the ones on the inside are all the same, along with the fir tree clips. That's all you need to put back in to get this panel back in. At this point, we're doing our 30-minute wait on our vacuum to make sure we have no leaks. I'll go give you a view of the gauges, and then we'll get it back down off the ramps and get ready to recharge it. All right, guys, if we kind of zoom in here, we can see we're 15 minutes into our 30 minutes. We're still sitting at minus 30 inches of mercury on the vacuum, which is what we want. We want to see that still in the next 15 minutes with this valve closed and our service valves open on both the low side and the high side, and then we're ready to charge it and rerun the performance test. All right, guys, 45 minutes, and we're still holding that vacuum, so no apparent leaks. Let's go ahead and get the recharge going. So the way I do these recharges is I leave the gauge set on. We take the vacuum line, we hook it up to a virgin tank. I don't like reusing the refrigerant, so I always use virgin. We're going to go ahead and open the main valve to the tank. And then we're going to take a note that we've got our gauge zeroed out, and then as we open the valve to the charge line, see, as we push on it, it changes. But what we're looking for is to use this to measure what's coming out. So the vacuum will pull some amount of the refrigerant into the system all by itself. And when you come up on top here, you want to make sure that your high side manifold valve is closed, because we're going to be charging through the low side, and that the low side valve is open. So open and closed. Now we're going to go start the engine and let the new compressor pull the rest of this charge through. So it's going to take time to build up, but if we look at our scale over here, we can see that we're slowly sucking out the refrigerant. So 0.65, 0.7, and then if we take a look over here on the vehicle, on this sticker that's on the front, we can see that the amount that we want to get in here is 1.5 pounds. So we're going to charge it up on the scale until we get to that 1.500 mark. All right, we're coming up on 1.500. Okay, there we go. We're going to close off this valve, and we're going to close off this valve. All right, so we tiddled it a little bit, so we're going to have to let a little bit more in there, just a little bit. All right, 1.5. Got this closed. We got this closed. We're going to pull the rest of this out, but first we're going to take a look at our gauges. And now we're down to 31, and looks like about maybe 180-ish, 185. So we're going to let this continue to run and normalize, recheck our outside temperature and humidity, and see if we're within range now. All right, guys, after sitting about 5 minutes to stabilize, low side looks like it's reading about 35 psi. High side looks like it's sitting around, I'm going to say 179 or 180 maybe. So much improved after this repair. All right, we've got to go back to our performance table after the repair because it's been several hours between this job and another job that we were doing, and it's gotten cooler outside. So the current temperature right now is 85 degrees, and the humidity is now 69%. So if we come over here and look at the ambient temperature, we can see here's 85 degrees is this range, greater than 60%. We should be reading between 26 and 38 psi on the low, which it appears we are, and between 164 and 231 on the high, which we are. So we are now currently in the good zone. Let's go inside and see what our thermometer reads. All right, guys, if we can zoom in here, we can see we're reading about 49 degrees, I would say. So 60, that mark is probably 50. So 49 degrees, 85 degrees outside, 69% humidity. That's a huge improvement. So I'll call this a repair. We're going to go ahead and evacuate the rest of the refrigerant that's in the high side, like I showed you earlier. So we'll use the we'll use the manifold gauge to draw what's in the high side into the low to capture what's in the lines, which is part of our 1.5 pound charge, and then we're done. If this video helps you, I'd appreciate you paying it forward by hitting that like button. If you got questions or comments, leave them below and I'll try to help. And as always, thanks for watching.